Okay, on the first one for the bell ringer, you just switch your X and Y. So watch, I'm going to write them switched, and mine might look a little bit different than the answer choices. So if I switched, I would have 3, 1, -1, -2, and then -2, -1, 0, 2. I switched them. Now, I don't see that as an answer choice because they always like for the X values to start smaller and go bigger. So that's why the X values are written different. Which answer choice did y'all get? Was it A? Yeah, it's A. Okay, do we understand that one? You just switched them. They just had them in a different order because they wanted their X values to be increasing. Tyler, up here. Okay, number 2, the inverse of the function. I'm going to do this on a separate sheet of paper so I have some room. We have y equals 5 times x minus 3. And y'all, there's 2 ways to do this. You could distribute it if you want to. All right, and then of course we're going to switch them to do. So when I'm finding the inverse, either way we'll get the right answer. X equals, no they don't, because you have to do what? You have to you flip to get the inverse, and then you have to solve for y. So this is the same thing. You could think, let me just divide by 5. I'm going to show you both ways. So I would get x divided by 5, if I divided both sides by 5, equals y minus 3. And then what would I do? I would add 3. X over 5 plus 3 equals y. And that's your answer choice. What did we say? B or G? Okay, same thing here. You could have added 3. I didn't do 15, did I? No. 15.
See, I did 15.
Yeah, it's 15. I don't know why I did that. X equals 5y minus 15. Okay, then you would have added 15. And then what? Divide by 5. So x over 5. What's 15 divided by 5? 3. So see how you get the same? You get the same thing. And they just wrote theirs, the 1/5 in front of the x. All right, that's the same answer. So that one was G. Oh, you've learned that before.
That's weird.
But it's right. It's the same. Number 3. What function, all right, is the inverse of this? Y equals the square root of x plus 5. So for my inverse, what do I do first? Switch my x and y. So I'm going to say x equals square root of y plus 5. And like Jessie Kate said, there's no answer that says that because we have to change it to y equals. So I would subtract 5. And then what do I do? Square both sides. So I would square all of that. And it's y. Okay, and that is answer choice C. They were saying that the domain x has to be a number bigger than 5. Because I guess what's 5 minus 5 maybe? That's because it would go away to 0. I don't know. They just wanted your domain bigger than 5. That wasn't important. You just wanted to find your inverse. The last one, y equals the square root of x minus 5. The first thing we're going to do is find the inverse. That's what it told us. Then we will find the domain and range of the inverse. So I switch my x and my y, and then I solve. Didn't I do this part already? Maybe not. I square both sides. So x squared equals y minus 5. Then what do I do? Then we add 5. So x squared plus 5 equals y. And it says, now the range. The domain is all real numbers. X can be anything. If you start from right here, x can be anything. It doesn't matter. What can y not be?
5.
It can be 5. It can't be a number that's less than 5. Because watch, what's 5 minus 5?
0.
And you can take the square root of 0. It's what? 0.
0.
Okay? But now, what if x was smaller than 5? What if it was 4?
Negative.
Then I would have a negative underneath. That's why they were saying it had to be 5 or bigger. Okay? Does that make sense? Kinda? I know y'all said that y'all weren't completely the best with that. So that was the last lesson we did. This next lesson, we're looking at square root functions. And I just want a big review. We kind of did this yesterday. It's very similar to yesterday. If you see something that has an x squared, okay, y equals x squared, then, and y'all, these aren't going to be the best graphs. I know, I'm just showing you. That's x squared, right? What if it was negative x squared? What would that look like?
Down.
It would go down. So if I had y equals negative x squared, it's looking like this. Okay? And then we did some that what if it said,
Sideways.
well, I'm not just there yet. What if I had y equals x plus 3 squared? Where did that one move?
To the side.
Yeah, to the left 3. Remember, it's kind of backwards. So it would be 1, 2, 3 to the left. And it's kind of going that way. I'd use my calculator or graph it by hand to get the exact points. Again, this is just an idea. What if it said, let me do a different color again.
What lesson is this? 8?
This is 6-8. This is the last one. What if it said, I didn't mean to do that, x squared minus 2? Where does that one move?
To the right.
Down.
Down 2. Why did it move down 2?
Because it's outside.
It's outside. If it's in parentheses, it moves left or right. And this is actually something we're doing in advanced math right now. I'm still doing all this with graphs. This moves left or right. This moves up or down. So I would go down 2. And then I'd have my parabola like that. Okay, that was my x squared. Now today, let's see, we're going to look at the square root function. Okay, and it looks like this. And we pretty much have done these. It's just like the top part of a parabola, but if it was a negative square root, negative on the outside, it would be the bottom part of the parabola. It's just the parabola turned sideways. We did that yesterday. Bless you. And usually it starts at this y-axis at 0 because what kind of numbers can we not have under a square root? We can't have negative numbers. So if I had just y equals the square root of x, then I would know it's going to start at 0. Square root of 0 is what? 0. I can't go to the left of that. What's the square root of 4 if I plugged in 4?
2.
So I would go up 2. And y'all, that's going to be my curve. I can also show you on the graph. That's a positive square root of x. That's what that function looks like. So what do you think happens when I do this? Y equals the square root of x plus 2.
It goes up to.
Nope.
To the left.
It goes to the left 2. All right, so watch. Remember, if it's inside there with the x, it goes to the left or the right. If it was on the outside, like way out here, turn the air off.
No.
So if it's negative, it goes to the right, and if it's positive, it goes to the left.
If it's negative, yes. What did you say, Emily? Don't turn it off? Oh, I thought you said turn the air off.
It was I said turn the air off.
Oh, for some reason I thought Emily did. Are y'all cold?
No.
Let's.
My legs are.
Okay, well, I'll turn it off in a little bit. We'll give it some more time. This one, so Tyler, yes, it moves to the left too. All right, so I know that point. If you want another point, let's plug in, I wouldn't plug in 1 because I don't know the square root of 3. Oh, I could plug in 2. Why am I plugging in 2? Because the square root of 4. What's 2 plus 2? 4. Okay, so I'm going to plug in, if x is 2, what's the square root of 4? 2. And then this would be my same graph. It's just moved to the left 2, right? It's the same kind of curve. And you would know it's not going to go beyond that point because any number that's less than negative 2 is going to make me have a negative in here. And it would say error. You're right. Is this kind of making sense, y'all? All coming together? Because we're going to be graphing.
Can I put it in my calculator?
Yes. So you may put it in your calculator as well. Do y'all see how you can just pick values, though? You can graph by hand. Because I can tell what way it's going to go. To me, it's just as easy to graph by hand, if not easier, than it is with the calculator. So let me do the first problem they give me. And I'll show you both ways. I'll give you, I don't know, just a few examples, and I'll let y'all get started on some. Because the first few are not difficult. Sorry, need a second. Well, it doesn't, messed it up a little bit. Okay, here's our first problem in the book. Y equals the square root of x minus 2. Where is that one moved? Down 2. I would know my starting point is down 2. And really, I just need one more point. I would just plug in 1, because what's the square root of 1? So if I did the square root of 1 minus 2, what is 1 minus 2? So if I plugged in 1, then I would get negative 1. And that's kind of my curve going that way.
You missed it out completely.
Okay, that's okay. Wait, what?
Why is it going that way?
It always does. A square root always kind of is that same little curve.
To the right?
Uh-huh. Yeah. If you wanted another point, let's plug in, I wouldn't plug in 2 because I don't know the square root of 2. Would I plug in 3? No. But what could I plug in 4? Yes. So if I plug in 4, what do I get for my y value? What's the square root of 4? And what's 2 minus 2? 0. So I would go over 4 and stay there. And see, it did pretty good. It's just that little curve. Now, say that you hate graphing these by hand. Go to your graphing calculator.
So they're always going to go to the right.
Yes, they're going to look the same. A square root, and we did these yesterday. A square root is always going to go up and over. But what if it said a negative square root? It's kind of down. It's going to curve down. All right, so anyway, I'm going to go to y equals, and I'm going to put the square root of x minus 2. And then I graph, and there it is, right? It looks very similar to mine. You actually have to have points that I can clearly tell where they are for me to give you credit for that, okay? Don't just randomly draw a little mark on your graph.
Are we going to have graphs on our paper? Or are we going to Let's go.
Yep. So then what I would do is I would press the table button, so second graph or second table, and there's a bunch of numbers to pick from. Would you pick this one?
No.
No, because that is a terrible decimal we don't want to deal with. So I would pick the 0, the 1, and the 4. Those are easy. No, you don't pick 1. You need probably 3 so you can see kind of where that curve is going. Okay, does this make sense, y'all?
Yeah.
Okay, let me do just one more or a couple more. What if I had, we have several. The square root of x minus 1. Y equals the square root of x minus 1. Without the calculator, where's that one moving?
To the right.
To the right one. This one moved down.
It's in there.
This one moved to the right. So I know my starting point is right here.
Wait, why is it to the right? Because it's
When it's inside with the x, it's always right or left. And remember, it's opposite of what you think. When it's outside, it's exactly like that's down 2. If that had been a plus 2, where would we have gone? Up
We
2.
can just plug that in the calculator and then...
Your calculator can do it all for you.
And then just find the thing.
Yeah.
Yeah, so this one's
Now-
like super easy.
So, but now I'm just trying to show y'all how to graph these without the calculator as well, though. What number would you pick for x? 1 wouldn't be so bad. Well, I already have it. Never mind.
I pick,
You could pick 2 for x, because what's 2 minus 1? Can you take the square root of that?
yes.
Yeah. So over 2 and up 1.
You can do 5.
Yes, very good. You could pick a 5 for the x. So go over 1, 2, 3, 4, 5. And then what's 5 minus 1? Square root of 4 is 2. So there you go. And it's going that way. It's just that little curve, like that part of a parabola that's sideways. Now, again, one more time with the calculator. I would go to y equals, clear that out, and I'm going to do my square root of x minus 1. All that's in the parentheses, right? Just like they have it. And then I press graph, and we'll see it move to the right one. There it goes. And then I need some numbers to plug in. So I would press second table, and guess what I have? the same numbers I pretty much picked. Okay, are we getting this? Yes. So y'all can do a lot of these, but I'll show y'all how to do number 4 and one like number 3 in a minute. Do y'all just want to? I'm not going to do number 5, but one like it. The reason I don't want y'all to do number 5, they want you, well, you are, but you're going to not graph it. Because if I gave you a problem that said, let's do this one. Let's go back to how would you solve for x? What would you do to get rid of the square root? Square both sides. So you get x minus 4 equals 121. And then what would you do? You would add 4 and you would get 125. That means on your graph, if we were graphing this, way up here, like our x value, where this graph would meet that 11, where this curved graph, that's not the best curve, would meet that 11 point, would be all the way over here at 125. So you would have to change your window a lot. I'll show you. Well, I don't have my graphing calculator. Ben, let me see it. Y'all aren't going to graph it because the numbers were so big.
We're going to solve it.
So you're just going to solve it just like I did and put your answer. But let me show you. If I graphed it and I put, 11 as one of my things, and then what's the other one? The square root of x minus 4. And I'm trying to find, where do these two graphs cross? Oh, I can't even see the 11, so I have to go up some. So watch, let me change my window. I'm going to go out to 50, which isn't high enough, and I'm going to go up to 25. Now watch, where are these graphs going to cross? It still hasn't, and I've gotten out to 50. Well, we know we're going to have to go all the way out to what? 125. So if I went, for my X max, let me go out to 150. So there's that first graph at 11, and there's where they cross, okay? That would be my answer. So to me, isn't it easier just to solve this one how we've been solving? Yeah. So I would go ahead and do number 5, just like this. Probably, sounds right.
You just square them.
So you just square and then you add. Because that number, we could never graph that on this paper, right? That would be ridiculous on this paper. But now, the next one, boys, the next one, let me find one similar.
When you just square that though?
No, we're not going to solve it. I am going to show you how to graph those.
So x minus 3 equals 144.
Miss Amanda, can I get a napkin, please?
Wait until I'm done with this problem, please. I want to find, I wish they had more of these.
Is that right? X minus 3 equals 144?
Tom? Yeah, and then you have to keep solving. So like number 6, I guess I'll just have to.
Can you, I need help with number 5. So what do I do after that?
What do you do after that?
After I got the x equals 144.
You don't get x equals 144. You got x minus 3 equals 144. What did I do to solve for x?
I don't know.
If I had x minus 4 equals 121, well, how do I get x by itself?
3. Oh, yeah.
Okay. So, and then you're done. And then you're finished with that one.
And then you just graph it?
No, you don't have to graph it. That one was too difficult to graph because we weren't going to graph all the way out to 125, right? Let me pause this and make one up real quick. So this one looks like number 6. I'm going to find where these two graphs equal, where they meet. So what I would do, yes, somebody was right earlier. They said, oh, you could square both sides, solve for x. Yes, you can do it that way and you'll get the same answer as me. But I'm going to show you on your graphing calculator, on your first y equals, you can type in square root of x plus 3. On the second y equals, do y'all see that? And I'm going to find where these two graphs
So
meet.
you have to put it in parentheses?
Yes, you have to put it in parentheses just like that.
Correct.
All right, and then you're going to find where the two graphs meet. And wherever your x value is, that's your answer.
I put. It's funny looking.
Is everybody good with that? When you graph, does it look like this?
Yeah.
So you have the two graphs. Now guess how I would find where they cross? When you're going down the street and two roads meet, what do they call that? An intersection. So second trace, number 5, and then you press enter, enter, enter. Yeah, it's 3x minus 4. Enter, enter, enter.
Wait, what'd you press?
You're not moving anything?
Well, I don't know why it didn't work. Hold on.
What did we press?
What do you press before enter?
Enter, enter.
I hate you guys.
Hold on. A second trace.
Second trace, and then what?
We find where they intersect.
And then click enter and enter.
And well, but that one didn't work on mine. That's the first time. Did that work on y'all's?
I just did the intersection. It gave me the little thing that I moved. I got 0.
That's not. Let's see. First curve. Second curve.
That ain't work, does it? Miss Casey, you told me wrong.
I got 3.5.
How'd you get it?
Hold on. Okay, let me show y'all. All right, so again, you have pressed graph. This one's weird. It's never done that before. So you press second trace. And normally, okay, and then we go to intersect. Does everybody understand that? We're going to find where they intersect. Normally, wait, I can press enter, enter, enter. Don't have to move anything around. But on this one, I press, let's see, I'm going to move it close to that. Press enter.
So I should move it to
Just close to the intersection. And then you'll press your enter button. And it should tell you X is 3.5. That would be my answer.
Well, I did number 6. I did number 6. And I moved it to the intersection. And it gave me negative 0.909.
Did you press it? Did you do that 3 times or just do it once? You have to press the enter button 3 times though.
X equals negative a little thing.
Huh? Kind of. It's similar to that, but we've never had to do that on the intersection. But y'all, real quick, if I had squared both sides like a while back, I got x plus 3 equals 3x minus 4.
Are we graphing?
Yeah, we're going to graph it in just a second. Shh, y'all just bear with me. All right, then I would subtract my x, 2x minus 4. I would add my 4, 2x equals 7, and then I would what? Divide by 2, and guess what I get for my x value doing it like that?
What happened?
3.5. There was no y in this one. You just, your x value is where they cross. That's what we're looking for. So I could have solved it this way.
I like that one.
This is how we've already solved these. We've already done
You
this.
just said screw the square root.
So, But I'm showing you now, though, you can solve them algebraically how we've done in the previous lessons. We've done this all before, where we just square both sides to get rid of the square roots. So I just bring down, and then we solved for x. But now I'm showing you, I could have just graphed the 2 equations and found where they cross. And guess what? That works the same. But if I tell you to graph and give you a graph, I want you to graph these 2. Do y'all know how to graph it on your paper from here?
Do I just click?
You do your second table,
We are graphing 5.
and you're not graphing 5, but you are graphing number 6. And then I would use about 3 on each. So for my first one, I would pick that point, that point,
So what do I do with my x value?
and that point. That's your x, you go over that many. And then your y value, you go up or down that many.
All of the other number is this 2.
Let me try. Y'all are doing y'all's, so y'all's is the square root of 2x plus 5.
You didn't just make it up.
Can we just do it
No,
randomly?
on mine it was fine. This one I didn't make up.
The one on the paper I did is all like some jack numbers.
I'm going to look at
What
it.
do I do with the negative one that I got for number 6? That's my x value.
Hold on.
And then now it's going from the left and goes.
Oh, it's just backwards. Because it was 2 minus x. That's why it was backwards. So, hold on. I'm going to my table. I'm going to graph my first one. Okay, here's some numbers. I would go left 2 and up 1.
Yeah.
Then I would go where? Over 2 and up 3. And let's pick one more. Do I?
Nothing else. There's 10 and 5, but it's too big.
Okay, then just go with that. Just go with those 2.
Do we?
So you make your curve. Make your curve.
Yeah.
Yeah, I got negative 1 too, but I don't know what.
Didn't I do that?
My allergies are.
You did negative 2.
That
We did
way.
negative 1, what do you do?
That way?
I don't know, I'm gonna grab it now.
I went left 2 and up 1, and then I went over 2 and up 3. Look at your graph. It looks just like that first curve right there.
Yeah.
Okay, that's that curve. Now my other curve looks like it's going backwards. So when I go to my table,
She's cuckoo.
It's like the one.
and I thought you were talking about me. I was like, what? So now I'm going to pick 3 points. So I'll do this -2 and 2. I'm going to go to the left 2 and up 2.
Now, wait, what
This
do
is
we do now?
sector.
You're doing your second graph.
Yeah.
So that's why I'm looking at Y2. I would go to the left 2 and up 2. Let's see if there's
see that. I see 2 and 1.
2 and 1.
Yeah, on my Y2 it says
Yeah, it's just -2 and 1, I think.
And then Y1 is blue and it says 1.
Did I put mine in wrong?
No, I got mine's right.
2x plus 5 and 2 minus x.
So I got 1 and 1. Like,
If I'm looking at my Y2, I get -2 and 2.
Yeah, that's mine.
Okay,
That's what mine looks like.
that's what mine said. Okay.
-2 and 1.
No, what about this one? Does it not have a 2? I'm looking at my second graph. I already graphed my first one.
Yeah, I just don't have my.
Oh, So for my second graph, I'm looking at the second one, this Y2. So I'm going to go to the left 2 and up 2. And let's do another point. I'm going to go to the right 1 and up 1. And then I'm going to do a third point since I have one right here. To the right 2 and 0. And y'all, that one is odd because what way is it actually going? Backwards. Okay, can y'all see that on your paper?
Go over to.
So you're going to have that one going backwards.
They didn't cross that -1 though. Mine crossed at like 1 So go over 2, up 1.
You would go, let me pause this.
Raw.
Left 2, where are you getting over 2 and up 1?
And left 2.
So we have, I wanted to show y'all something else. I don't have it on this sheet, but I'll do that in a minute. The square root, y equals the square root of 9x plus 18. They just want you on this one. You'll notice, boys, in the back, your instructions say rewrite the function to make it easier to graph. What do y'all notice? What number goes into 9 and 18? And is 9 I made this up while y'all were talking.
Oh, geez.
So what number goes into 9 and 18? 9. And is it a perfect square?
Yes.
So this is, if I rewrote it, let me just take it step by step. That would be x plus 2, right? All I did was I divided the 9 out. I just backwards from distributing, like factoring it
I
out,
was just trying to.
right? So that would be 9x plus 18. Is if I multiplied it back, wouldn't it be 9x plus 18?
Okay, no,
Yeah, it's-
Because if you do 9.
I factored a 9 out. I divided the 9 out. I factored it out.
9 divided by 9.
And yep, so I got my x. 9x divided by 9 was x. 18 divided by 9 was 2. It's just backwards from distributive property. So what is the square root of 9?
3.
3. And then I still have an x plus 2 underneath. No, we don't have to do this, but they do want me to teach this to you. You don't have to do that to graph. You could have graphed as is on your calculator. So if I wasn't having my calculator, though, where would this one move? To the left,
Over.
to the left 2. And then when I have to the left 2, this was something I wanted to show y'all. I'm going to start at the left 2. Now, normally, I would go up 1 and over 1 for my first point, and then it would round off. How far up am I going to go on this one?
3.
Up 3 and over 1. Okay, and then, so I've already got 2 of my points, but I'm sorry, Ben, I know I have your calculator again. I will go ahead and graph it. 3 times the square root of x plus 2. You could, and I'm gonna show you if it, boys listen, I'm gonna have to move y'all. So there it is, there's my graph, and see how much steeper it's going because of that number 3? And then if I found a table of values, -2, 0, -1, 3, I already did those, over 2, up 6. 1, 2, 3, 4, 5, 6. So see how it's going steeper than normal? Okay, now what Jessie Kate was saying was what if I just put it in there like it first was, the square root of 9x plus 18. Guess what? When I graph that one, guess what it is? The same exact thing. They just want you to rewrite it just so you can kind of see how we're using math and that we've already done. Rewrite it and graph it. Does that make sense?
Yeah, like, okay, if we did R as like on number 7.
So what
does
goes?
3 go in?
Nope, it's 9.
No.
9 is a perfect square. Yeah.
So it'd be like.
That's right.
Is this, did I do it right?
X minus.
Hold on, let me pause this one.